Okay, let's begin with the next two checkpoints, one-dimensional motion. Problem 1. Find a false statement regarding a particle. In reality, a particle does not exist. It does not exist, correct? A particle does not have a volume, but has a mass. Sure. The density of a particle is infinite because the density rho is mass divided by volume, and particle does not have mass. The approaches zero, so density must be infinite. Without mathematical concept of particle, one cannot describe nature correctly. Absolutely wrong. The particle is a convenient tool, convenient mathematical tool, but it does not exist at all. There is no. I'm a particle physicist, and the particle is particle represents elementary particle, the fundamental building block of nature. But that mathematical particle is not a building block; it's a mathematical convenience. 2. Find a false statement about the one-dimensional position vector. In one dimension, we can draw a straight line, and any points represent the position of a particle. Okay, so if we choose the reference point as the origin, then we can choose a point P and connect the origin and a given point. Draw an arrow, then we say this is a position vector x. And position vector x is represented by a basis vector. In here, we have only a single line as a unit vector. We usually use the unit vector as a basis vector. And this basis vector is E1 hat. Hat means the length is 1. And then we multiply a real number that has a dimension has the dimension of length. This is not a mathematical number, it's a physical. In physics, we write it in italic letter, then it represents the physical quantity. That this is has the dimension of length. Okay, this is a way to write down a vector. But in here, we have two directions, either E1 or in opposite direction, minus E1 hat. So this is E1 hat, and this is E1 hat minus. So you can choose either this one or this one for convenience. So we can, it's better not to use attach a negative sign on it. So I prefer this one to the minus E1. But you can do this. There is no, it is not forbidden. So we can choose either one. But choosing this one and choosing this one, you should only a single basis vector because it's a one dimension. In two dimensions, we have to choose the two basis vectors. Anyway, we have a single basis vector E1 hat. X is a real number, all right, but it is not a mathematical real number, a physical real number. That means it has a magnitude and its own physical dimensions of length. Okay. When you call the dimension, it is always a plural. For example, length has a single power. However, it is a convention to use a plural. E1 hat, the hat represents a unit vector. In here, we have only a single direction. The vector divided by its own magnitude is the unit vector. Hence, E1 is of dimensions of length. No, it's wrong. X has the dimension of length, and this is a dimensionless. It is a dimension is scaled out. It is divided. Dimension of length divided by dimension of length. So this is dimensionless. This is pure number. Find a false statement regarding the unit vector E1 hat in one-dimensional Euclidean space. E1 is invariant under translation, right? E1, this E1 from the origin to point 1 and 2, this is also E1 hat, and this is also E1 hat. Whatever amount you translate this unit vector to anywhere else, they are always the same. It is invariant. Invariant means a variant means it does not vary. Change. It does not change. Invariant. Descartes is nothing to do with the unit vector. Descartes created the Cartesian coordinate. So Descartes is the creator of the Cartesian coordinate. Okay. 4. Find a false statement regarding the one-dimensional vector. X is a positive if X is parallel to E1 hat. In one dimension, we have E1 hat. X is either parallel or, in this case, is opposite direction, anti-parallel. So it is along this direction. You can take a scalar product. This one is X. When it is a parallel, this X is a positive. If I compute X dot E1 hat in this case, this is opposite. So it is a negative. X is a 0 if the magnitude of X vanishes. Sure, X is a 0. X vector equals X times E1 hat, and the magnitude of unit vector is always 1. It is a 0 only when the magnitude becomes 0. The unit vector E1 has the length 0. Stupid. E1 is always, unit vector is always of magnitude 1 and dimensionless. 5. Find a false statement regarding the scalar product of the two vectors in one dimension. So remember, it is one dimension. Even though they do not learn scalar product in elementary school, this one, any elementary school student can do this job. X dot X is a scalar product, so it's just X squared equals 0. Solution of X squared equals 0. The X equals plus minus 0. So 0 is unique. So if and only if means if, only if. So it is if and only if. Sometimes mathematicians use this kind of notation, but if and only if means equivalent, the same. Equivalent, the same. X dot y is a positive if and only if x and y are of the same orientation. Yes, right. There is no way to have some angle, theta, because it is just a one-dimensional case. It is either parallel or anti-parallel. If they are parallel, x dot y is a positive. If x dot y equals 0, then x at both x, either x or y equals 0. And x dot y equals x times y always. It is impossible to have x dot y negative. Really? No, if they are anti-parallel. If you are interested in here, I can write it. X equals x times e1 hat, and y vector equals y e1 hat. X dot y equals x times y times e1 hat dot e1 hat. And unit vector, the same, and its magnitude is 1, so xy times 1, so xy. It's always xy. Number 6, find a false statement regarding the distance between the 2 points whose position vectors are these. Okay, the distance is x minus y. Wrong. Distance is a magnitude of difference. So you can do this x minus y, either x minus y or y minus x. But you have to take the absolute value. Absolute value. Absolute value means the magnitude of a vector. So it's wrong. But negative distance is forbidden. Sure, is a positive definite, and at least it should not be negative. It can be 0 when they are both of them are the same. The distance becomes 0, the two identical points. The distance can be expressed as this. You learned in middle school, absolute value of a real number can always be expressed as a square root of a squared, because a square root is a positive root of a quadratic equation. So a squared is always a positive, either positive for any real number a, because a square is all positive, and it can never be negative value. But sometimes, if you consider complex variable, it can be negative in some case. All right. In one dimension, the square of two vectors, I mean, x vector squares is a scalar product with its own, and that is magnitude square. Okay, everything is the same. So we can write it in this form, and remember, this is italic letter. This is a component, and this is a vector. You have to distinguish. If I write down, I usually put an arrow on top of a letter, but if in editing the file, I use the bold-faced one that represents a vector, okay? Number 7. Find a false statement regarding the periodic motion of a particle in one dimension restricted to the region 0a. This is closed interval. You learned in high school, right? 0, 1. Everybody knows, right? How can I write it in that case? 0, 1. This is 0, 1. Understood? And then what happens if I consider this one to infinity? In that case, this is 0, 0 to infinity, all open. So this is open, closed. So in here, the particle makes a one-dimensional motion from 0 and A. This is the x-axis. And this is an integer, n is an integer. We have a capital T, the scale of time, and the position of this particle is a 0 at t equals 0, t equals t, t equals to 2t, and so on. And then we have 1/2 of t, 1/2 of t, haha, 1/2 of t. And then 3/2, 5/2 in here, aha. So it is oscillating, so oscillating motion. Come back and forth. The displacement at 1/2 t and until t, so from here to there. So at 1/2 t, it used to be a, and at t, it becomes just 0. So this is the displacement, what I want to compute. So this displacement is minus a e1/2. Understood? Because the x1t, x capital T equals 0 vector, x 1/2 t equals a e1/2. Subtract. Minus a e1/2. Right, this is the answer, right? Next, the average velocity during the time interval is this. The displacement, this is the displacement. What is the time? What is the time from here to there? So delta t equals t minus 1/2 of t, so 1/2 t. So divide this displacement by delta t, so 1/2 t. So if you divide this one by 1/2 t, the answer is minus 2a over t e1/2. Because it is a velocity, it is a vector, you have to include the unit vector in here. Average speed during the time interval, average speed, the same interval. Velocity, speed, they are the same in magnitude. The magnitude should be 2a over t. And the speed is not a vector, it is a scalar. It does not carry any direction. So this is wrong. And factor of 2 is missing in here. the average velocity during the time interval 0 to 3t, right? Let's see. It is always a 0. X vector at 0 equals the 0 vector. X at 3t is also a 0 vector. Subtract delta x equals x 3t minus x 0, the 0 vector. And then whatever time is required, because the delta x is exactly 0, average velocity is exactly 0. That's right. A. Find the false statement. If the position of a particle is given by, this exponential function. Is there anyone who does not know exponential function? Everybody knows, right? Can you hear me?
Yes.
들려?
네.
You know exponential function, right?
Yes.
You know how to take the derivative. You know how to take the derivative. You know the answer?
Yes.
So if you know how to take the derivative of an exponential function, then you can take the derivative any polynomial function. You know that? Actually, the student must learn exponential function ahead of polynomial. These are polynomials because it is always possible to write down exponential log, and it is a log x. If you know how to take the derivative of an exponential function, then you can apply chain rule. Then for arbitrary power, for example, you first learn for n equals 1, 2, 3, 4 integer, but you can extend it to the half integer, for example. So you can take the derivative of a square root. This is an application of this. And every detail is introduced in X2, I think. Let's see. Not yet. Okay, not yet. But later we will study detail. But at the end of from this part until the end of this checkpoint, you should be familiar with the exponential. Anyway, have you heard about these kind of expansion? This is a Taylor series expansion of sine and cosine. And Taylor series expansion of exponential is somewhere. You know binomial expansion. Do you know how to expand this? You know? So what should I do if I have a plus b to the n?
Yes.
You know how to do that. So this expansion is, this is two terms. two terms. So this kind of exponential is called the binomial because of bicycle, two. This method can be extended to A, B, C, D, and you know how to find the combination, this overall factor for A, B, C, D, alpha, beta, gamma, delta, sum over this. In this case, we say it is a multinomial expansion. Anyway, you first do the binomial expansion of the series, and then take the limit as n goes to infinity. Then you can find the expansion of this can be expanded in powers. Finally, you end up with a very simple form. This is the power series expansion of the exponential function, and any high school student can do this job. And it is a very, very important. You know how to write pi? Is it correct? Am I right? Is it pi? It's an approximation. It's an approximation. If you go ahead, the accuracy of this number increases. But however, it is not exact when you stop somewhere. Just like this expansion, this is something like you add 3 to 0.1 plus 0.4 plus 0.001, something like that. So this number becomes smaller and smaller, and your error becomes smaller and smaller, right? Something like that. Even any function that has derivative to all orders, first order derivative, second order, third order, and nth order. If it is differentiable function, in that case, it is always possible to expand as a sum of polynomial. Very interesting. Polynomial means x to the 0th power, first, second, and third, something like that. So if you increase the number of the terms, the approximation of this exponential function becomes very accurate. And it should be exact only if you can make a summation to the infinity. That's the problem. Anyway, exponential function has a very interesting feature like that. If you expand this, exponential function is 1 plus x plus 1/2 x squared, 3 factorial x cubed, something like that. You know, this is f of x. What is f0? f0 means exponential 0. What is this? You substitute 0. Sure. What is the first order derivative? First order derivative is this dies, but it becomes 1, it becomes x. So this guy becomes this guy becomes this, something like that. So if you find the answer, derivative is itself. So that means first order derivative at 0 is still 1. That means exponential is a very unique function whose derivative at the origin, here n means nth order derivative, it is always 1. Haha. From here, we can learn this. Any differential function has the form okay. If you know the nth order derivative at the origin, you can find the power series expansion, this polynomial expansion of that function. In here, exponential function has the derivatives all 1. So if I substitute this, then, sorry about that, this is k. This is the power series expansion of exponential function. But you know how to find the derivatives of a sine and cosine at the origin. That is very simple. It is all simplest case, but sine and cosine has a, so if you understand that this Taylor series expansion of the exponential function, the Taylor series expansion of the sine or cosine function becomes trivial. So we will frequently use that one. So let me derive the expansion. Now we know exponential is a sum over k equals 0 to infinity x kth power k factorial. So why don't we substitute, I equals square root minus 1. So I squared equals minus 1. And using this relation, I 2n equals minus 1 n. I 2n plus 1 equals minus 1 to the n, oscillating n I. All right. So any even power, 2n is even, and 2n plus 1 is odd. This odd number and even number. Any even power has this real number, and any odd power of I becomes a pure imaginary number with oscillating sign. Let me compute this. Ix. It can be divided into, k can be either of the form 2n or 2n plus 1, something like that. So any even is a 2n x 2n, and n runs from 0 to infinity, plus n goes from 0 to infinity x 2n plus 1 to n plus 1. But I have missed I in here. We make use of this one. This one is minus 1. Minus 1 to the nth power and we have 2n factorial x 2n and 0 to infinity. And this one, copy this one, as I bring single out this I in front of the summation, 0 to infinity, factorial is missing. We have 2n plus 1 factorial and minus 1 and x 2n plus 1. And actually, you will find that this one is derivatives of cosine at x equals 0. You will find it later. And this one is cosine x. And this one is the derivatives of sine at the origin. So it is I sine x. Actually, this is the reason why we can write it e to the I theta equals cosine theta plus I sine theta. So we will frequently make use of this and this Taylor series expansion of cosine, Taylor series expansion of sine, and Taylor series expansion of exponential function. You must be very, very much familiar with this expansion all throughout this course for 1 year. All right. So if I substitute n, these are even numbers and odd numbers, the result is very trivial. X plus minus oscillating. So 1 x squared x to the fourth. So this is, cosine is an even function. Even left-right symmetry, right? Cosine is a 0. And sine is odd function. Odd function is, sine is this kind of form, a 0. They are opposite, right? So this is an odd function. Why odd? Powers are odd. F of minus x equals f of x is even. F of minus x equals minus f of x, we call this is odd. Why odd? Powers are odd. Taylor series expansion has only an odd power. So this is odd function. Taylor series expansion of cosine has only even power, 2, 4, 6, 8, and so on. And the denominator is very simple, 2, then 2 factorial, 4, 4 factorial. You just flip the sign, plus minus, plus minus. Here, 1, 3, 5, 3 factorial, 5 factorial, 7 factorial, and so on. Trivial. Now you are familiar with this kind of expansion. Okay, so if this is a physical quantity where x is a displacement of a particle, then the dimensions of k is inverse power, inverse single power of time. That's wrong. The reason is that, first of all, exponential function can be expanded. For example, 1 plus kx plus 2 factorial kx squared or something like that, and so on. You'll find this is a dimensionless, right? Then you add some dimensionless number by something else, and this one must be dimensionless too, right? One cannot add any dimensionful number to a dimensionless number. Therefore, exponential function has the argument, some argument, that one must be dimensionless, because this power series expansion gives all possible powers to the infinity if the addition is defined. That is true only if this whole thing is dimensionless. We know X is dimension of dimensions of length, so this dimension must be destroyed. This one can only be cancelled by the dimension of K that must be inverse power of length. Okay, so they cancel. So it should be length inverse. The same is true for sine and cosine. Sine and cosine has a power series. So this one in mathematics, it is always they do not they are mathematicians do not know what physical dimensions are. So they can always add, but in physics, every number is not a mathematical number, but in general, they have physical dimensions. So this x and this x is different. This x is displacement having dimensions of length. This mathematical x is just a number. You have to distinguish. Next, the displacement of a pendulum, okay? Pendulum, oscillating pendulum can be approximated in terms of a sinusoidal function. That's fine. Because of the sinusoidal periodicity of a pendulum, do you know Huygens? Huygens patented the pendulum clock for the first time, and Galileo made use of the periodicity of pendulum for the first time. The sinusoidal function is either sine or cosine, right? It's a periodic function, sinusoidal function is either sine or cosine, okay? That are related to each other by a finite translation and reflection. Perhaps the middle school students knows very well about it. The expression such as sine kx minus omega t is unphysical. It is a really physical one. Kx omega t. In here, they are subtracted. So, and this is a sine. Sine or cosine can be expressed as a power series. So this argument must be dimensionless. So kx is dimensionless. Omega t is dimensionless because x has the dimension of length and time has the dimension of time. So omega has the dimension of a time inverse and k must have the dimension of a length inverse. Understood? So this is dimensionless. This is dimensionless. They can be added or subtracted. If a sinusoidal function appears in an expression for a physical variable, then the argument of the sinusoidal function must be dimensionless. Correct. Find the false statement regarding the following plot. There's a straight line, time, and position. This two-dimensional plane looks like a Euclidean space mathematically, right? Physically, the space Tx does not construct a Euclidean space because the mismatches in dimensions of the two coordinates. Right, because this one represents the dimension of time, this one represents the dimension of length. They are of different dimensions. For example, x or y, that's fine. This is dimension of length, dimension of length. The slope, this is a slope, multiplied by the unit basis vector, E1 hat, along the x-axis represent the average velocity of the particle. That's fine. Area of a polygon, area of the polygon on the tx plane has the dimension of length squared, stupid. This is dimension of time. This is of dimension of length. The area must be length times time. This one is the answer. This one is wrong. Find the false statement regarding the motion of particle with the displacement. This is oscillating. You know this cosine has argument this, and this is unit vector. Particle is isolated in the region. You know, cosine oscillates from -1 to +1. The range of x is -a to a. Particle makes a periodic motion with the period. It has a 2 pi t c. Cosine has a period 2 pi. Right? The whole thing has a period 2 pi. Then it becomes a period t. So that period is c. Dimensions of a, you know, cosine, sine, exponential, they are dimensionless. So, and the unit vector is dimensionless. So the whole dimension is carried by the amplitude. Okay, these two are of the same dimensions. The velocity of the particle at, you can just evaluate this one. 12. Hey, all these are very similar problems. Let me pass. Find the false statement regarding Leibniz rule. So these are Leibniz rule. You must be familiar with everything. We have double derivative, a plus b squared, a squared 2ab plus b squared, something like that. If I take the derivative twice, then if I take another derivative, I can take the derivative of the first term and second, oh, sorry about that. First one, second one. First one, second one. First one, and second one. Hence, it should be 2 times eta theta. You know, a dot is a time derivative. Okay? Double dot is double time derivative. They are shorthands. Okay, elementary school students can compute the area of trapezoid. Double the trapezoid, you find parallelogram. The area of parallelogram is just the base times the height, but you have double the area, so you need to divide it by factor of 2. So one half base and height. So this is a very simple relation for the energy conservation. This is a work kinetic energy theorem of Coriolis. It's a simplified version for the constant acceleration case. So I believe you are all familiar with these formulas because every high school students learn this, right? Am I right? Next. All right. Find the false statement regarding the exponential function. This derives from the definition of exponential, Euler's definition. So you need to reproduce this one. Why don't we put an X on it? Okay, to make use of this, why don't we make use of this? But I have divided X, so I need to cancel this one by multiplying it by X, and then replace this one as something like m goes to infinity, 1 plus x over m and m. Then, haha, this exponential function can be extended from the fundamental definition of Euler number. Okay. Now we know that, right? This one and here, 0 is missing. Derivative of exponential function is always itself. Now it is a very interesting formula, and it is a very, very powerful extension of the exponential by making use of derivative. So we know exponential x is this. K runs from 0 to infinity, x to the k, and k factorial. Why don't we just we define this one by same power series, except that we just replace this one as a power of a derivative operator. It looks, perhaps you have never seen this, but it is a very, very compact formulation. This one is showing the arbitrary Taylor series expansion. Memorize. And again, the original definition of Euler number can be made use so that this expression is expressed in terms of this. All right, whatever variable, I just replace this one by alpha. Anyway, this alpha is dimensionless variable too, right? And let me attach a number. This is a, this is constant. Then what happens is exponential a dx. Everything is the same, except that I just substitute a as a number. Then it becomes a k, k factorial, and the kth order derivative. And if you apply this operator to any differentiable function, then you will find a very compact expression. This is just action of translation. You know, a function f of x can be translated by a along the x-axis, then the resultant graph is f of x minus a. All high school students know. You know, you understand what it is?
Yes.
Translate graph.
Yes.
Okay. This effect is just if you just flip the sign by minus, then this operation is very interesting. The final result is the translation. So it is a very important operator. These are tedious job, but very interesting. I ask you to everyone in this class follow this mathematical calculation. Is you should be very familiar with this. Then your life will be very easy. Like after this. Haha. These are all tedious job, but you remember. At the end of the day, they are all useful to find the Taylor series expansion of sine and cosine. Oh, where is this? Is there anyone who do not understand this? In this class, I believe everybody knows this. If somebody do not know how to compute this, just later in a few lectures we will study how to reproduce So if you know this, you can make use of the definition of derivative f of x plus delta subtracted by x divided by delta and take delta goes to 0, and you use cosine and sine from x to delta, and sine x plus delta, and substitute x and delta and take the limit, delta goes to 0. So for example, use this expansion formula, but later we when we study cross product, that is a vector product, we study rotation. And then we make use of two-dimensional rotation to reproduce these results. And also, we find the same formula by applying the rotation on the complex plane. So anyway, you should be familiar with all these calculations. And actually trivial. And you will find this minus 1k. These are the derivatives at the origin, x equals 0. That's the reason why this cosine has derivatives with oscillating sign for the even powers only, and all odd powers becomes a 0. That gives the Taylor series expansion of this form, right? You know, oh, this is wrong. This is a minus 1 to the k, right? Sure. All right. These are I have already explained. Let's see. E to the I theta is now cosine theta plus I sine theta. And e to the minus I theta equals cosine theta minus I sine theta. Because sine is an odd function. Sine minus theta equals sine theta. Cosine is an even function. Cosine minus theta is cosine theta. So if I add them up, we have two cosine, e to the I theta plus e to the minus I theta. If I subtract, I have the 2I sine theta, that is e to the I theta minus e to the minus I theta. So cosine theta equals 1/2 exponential I theta plus e to the minus I theta. Sine theta equals 1/2I e to the I theta minus e to the minus I theta. Okay, that's it for today. Is there any question?
교수님, 그 테일러 시리즈가 그래서 뭔가요?
테일러 시리즈. 우리 3.141592 이렇게 아까 얘기했잖아.
네.
할 때 초등학생이 3.14까지 알지. 근데
네.
좀 더 정확하게 하면 뒤를 계속 다루면 되지. 이게 점점 가면서 더 작은 양이지. 작은
네.
양을 더해서 정확한 값에 가까이 가지.
네.
오케이? 그런데 아까 sin x는 누구나 이런 거라는 걸 알지. 그러지?
네.
sin x 그림을 이렇게 그릴 줄 알잖아. 그런데 x가 작으면 사실 커도 되는데 작은데 0 근처를 여기 0이 있을 때를 보자고. 그럼 얘는 여기에서 작으면 대충 이렇게 접선을 잡아서 이게 x하고 비슷해. 근데 사실은 달라. 여기 3.14까지 얘기하면 x라고 얘기해도 돼. 근데 난 좀 더 정확하게 하고 싶어. 보니까 약간 오버돼서 좀 숙여야 돼. 얼마만큼? 3 팩토리얼 분의 x 3 세제곱만큼 줄이니까 좀 더 이 사인에 가까워져. 근데 나는 좀 더 정확하게 하고 싶어. 그러면 5 팩토리얼의 x의 5승. 요게 x가 1보다 작으면 이게 지수가 늘어나면 늘어날수록 작은 숫자를 더하는 형태가 되는 거예요. 그러니까 숫자 하나에 다가가는 것도 있지만 함수를 이렇게 사인은 이렇게 꼬불꼬불한데 x제곱, x세제곱 이건 전혀 다른 모양인데 희한하게도 얘네들이 마치 베이시스처럼 우리 그 카테시안 코디네이트 x1 햇, x e2 햇 이거에 계수를 붙여서 벡터를 딱 리프로듀스 하지. 이 컴포넌트를 A, B 그래서 순서상으로 만들면 임의의 벡터를 표현할 수 있듯이 어떠한 미분 가능한 함수도 폴리노미알을 무한히 전개해서 영원히 가까이 가게 할 수 있다라는 거야. 신기하지? 그 이유는 그냥 그렇게 되기 때문인데 핵심이 뭐냐? 우리는 이 무한대까지 다 하질 않거든. 할 수가 없어. 이걸 다 하다 보면 우리는 죽어. 시간이 많이 걸리잖아. 그러니까 대충 하는데 엉터리로 하는 게 아니라 내가 원하는 만큼의 오차를 허용할 수 있다면 그거 안에서는 대충 해도 되잖아. 근데 2배, 3배 답이 틀리면 큰일 나는데 내가 정확하게 하고 싶으면 그러면 몇 항까지 하면은 오차 범위를 1% 이하로 줄일 수 있다. 0.01 이하로 줄일 수 있다. 그것만 알면 필요할 때 대충 해놨다가 정확하게 해야 할 때는 이 전개 항을 늘려서 정밀하게 오차를 줄일 수 있다는 거지.
테일러 시리즈
왜냐하면
그러면 그 삼각함수 같은 거를 좀 더
음.
정확하게 표현하기 위한 방법 같은 건가요?
임의의 미분 가능한 함수를 폴리노미알 이런 건 x의 n제곱 이런 계산은 너무 쉽잖아. 사인을 통째로 계산하는 것은 머리를 잘 쓰면 익젝트하게 할 수 있는데 어프록시메이션으로 대충 어림 짐작을 해서 계산을 할 때 어떤 오차 한계 내에서 항상 정밀한 정밀도를 유지하면서 폴리노미알로 계산할 수 있는 그런 장점이 있는 거죠. 그러니까 여기에서 이제 더 나아가면 이제 물리 현상을 기술하는데 이렇게 폴리노미알로 표현하기도 하지만 어떤 때에는 이 사인을 sin x, sin 2x, 3x 이거로 전개하는 법도 있어. 그러니까 일종의 이런 걸 베이시스라고 하거든. 그러니까 어떠한 일반적인 모양인데 그 모양을 다른 단위로 나누어서 걔네들의 성분으로 쫙 합쳐서 표현을 하는 거지. 그러니까 실제 그 컴퓨터로 사인을 그릴 때도 사인을 그리는 게 아니고 이런 식으로 테일러 시리즈 전개를 해서 어디까지만 해서 트렁케이트 시키고 버리고 하게 돼 있어. 오케이. 그 자세한 거는 시간이 지나면 익숙해지면 알게 될 거야. 왜 이렇게 하는지에 대해서. 오늘
예.
많은 걸 배웠는데
근데
시간이
한국어로 테일러 시리즈를 뭐라고 하나요?
시리즈는 한국말로는 아마 급수라고 할까? 테일러 급수라고
아,
할까?
네.
시퀀스가 수열이고 수열을 합하면 급수가 되고 시퀀스의 썸을 시리즈라고 해요. 오케이?
예,
다음
감사합니다.
시간에 봅시다.